right, so welcome to the final exam review session for Math 123. We're going to be going through a bunch of different examples today, and hopefully this helps you review for your final. So first thing that I want to talk through is what you can kind of expect for your final exam. So it is a cumulative exam, but that being said, there is more of a focus on the later sections in the course since you have not had yet had a test on this. So there are 10 multiple choice questions and one free response question that comes from units 1 and 2. So those are sections 1 through 12. And then there are 18 additional questions that come from unit 3. So you can see about twice as many almost from the kind of last section that we've covered. It is 120 minutes long, so you have 2 hours to complete it. It is a proctored exam, just like the others, so you can either choose to use ProctorU or you can go take the test at a testing center. You are welcome to use your scientific calculator, and then you also will be provided with a formula sheet, which is the same one that you were provided with last time. And then this exam is worth 25% of the grade, so slightly more than the rest. So let's go ahead and do some review stuff. Whoops. Backwards. Okay, so let's try this one here. So let me get my pen. All right, so it says that a blueprint has been created for a house. On the blueprint, the width of the house is 2.5 feet long and the length is 3 feet. The actual house is going to be constructed with a desired width of 60 feet. What is the length going to be of the actual house? So I'm just going to kind of make myself a note over here. I'm going to put my blueprint numbers on the left, and I'm going to put my house on the right, okay, just so I'm kind of consistent. And then the other thing that I have is I have a width and I have a length, all right? So you could switch any of these around if you wanted to flip length and width or blueprint and house. You could even have house in the numerator and blueprint in the denominator. It doesn't really matter. You just need to make sure that you're consistent. So basically, now that I have these kind of like 2 different dimensions set up, I can just plug in my numbers. So on the blueprint, the width of the house is 2.5 feet. So I'm looking for blueprint, which is right here, and width, which is right here. And that's going to be 2.5 feet. So I'm going to put a 2.5 there. And then the length for the blueprint, which is going to be kind of down here, is going to be 3 feet. So that's going to be this number. And then it tells us that the actual house is going to be constructed with a width. So width is in the numerator. The actual house is over here. So I'm going to put my 60 here, and then this is going to be my x. So then all I do is I multiply. So I'm going to have 2.5x equals 3 times 60. And then we're going to go ahead and multiply. 2.5x equals 180. And divide both sides by 2.5. And we'll see what we get. I'm going to put my answer over here. So let me get my calculator out. 180 divided by 2.5. Oops. And I get an answer of 72. And then this is going to be feet. All right, so that's my answer for that one. Now, you kind of always want to make sure that your answer makes sense. So in this particular case, the width is 60 feet. I know that the width of my blueprint is slightly smaller than the length, so it does make sense that I get an answer that is slightly larger for the length of the actual house. So that's going to be that one. And then let's look at the next question. So I just kind of have these all sort of scrambled here because this is what you might expect to have, oops, on your actual exam. So let's see, get my pen back up here. Okay, so April's salary is shown in the table below. Calculate the absolute and the relative change and use each in a sentence. Okay, so absolute change is going to be new minus old. So in our case, I'm going to have my new salary, which is April's $51,800, minus the old, which is $34,100. And then we're just going to subtract those two things. So 51,800 minus 34,100. It's going to be $17,700. So that's going to be my answer there. So that's my absolute change. So to use this one in a sentence, I'll just kind of state it instead of writing it. But you could say that April is making $17,700 more in 2018 than she was in 2010. That would be a perfectly acceptable thing there. And then for the relative change, we take new minus old, and then we divide by old. So in our case, we already found new minus old. That was 17,700. And then we divide by our old, which is 34,100. And we're going to get some kind of decimal answer that then we can change into a percentage. Let's see, 34,100. I get like 0.519. Depending on what it tells you to round to, you might want to just leave it at 0.52, something like that. But this I would change to maybe 52% or 51.9%. So we could say that from 2010 to 2018, April got a 52% raise or is making 52% more. So something like that would be totally fine. Anytime you have time, new is always going to be the more recent one, and old is always going to be the older one. All right, let's take a look at another one. Okay, so suppose that Angie has a credit card with 18.99% APR. She purchases textbooks for $450 on the first day of the month and plans on making only, I put his minimum payment, probably her minimum payment each month. Fill out the table below. So one other thing that I'm missing here is it doesn't tell us a minimum payment percentage. So let's just make one up. Let's say 5% is the minimum payment. All right, so that'll always be given to you in the question. This one I just forgot it. So 450, that's going to go in kind of my first spot here. And then in order to get the finance charge, we multiply by the APR, which is going to be 0.1899, and we divide by 12. Okay, so all we're going to do here, and this is going to be kind of tiny, but I'm going to take 450 times 0.1899 and divide by 12. It's a little bit messy. And let's see what we get. 450 times 0.1899 divided by 12. And we're always going to round to the nearest penny for this. So I get $7.12 for this one. So $7.12. All right, so that's how much she's going to have to pay in terms of interest, basically. So the new balance is going to take the beginning balance, which is $450, and tack on that finance charge, $7.12. So if we add those two, we should get $457.12. So something like that. So this is always going to be the beginning plus the finance charge. All right. Beginning balance plus finance charge. And then to get the minimum payment, all we do is we take whatever was our new balance and we multiply by our minimum payment percentage, which in this case, I said 5%, so we'd multiply by 0.05. So we're going to take 457.12 times 0.05, and I get an answer of $22.86, because it's like 0.856, so we should round up. All right, so that's our first line. And then our beginning balance here, we're going to find this the next month, basically by taking our new balance, so new balance, minus the minimum payment. Okay, so we're basically taking what it is that she owes, which is $457.12, and then subtracting this minimum payment right here. And that gives us her beginning balance. So $457.12 minus $22.86, I get $434.26. All right, so that's her beginning balance here. And then we just kind of continue on. All right, so we keep doing the same thing that we were doing. So I'm just going to go ahead and kind of walk through this. I'm not going to put all of the work on there, but I'm going to take the 434.26. I'm going to multiply by my APR, which is the 0.1899, and then I'm going to divide by 12, and I get an answer, should be slightly smaller than the previous answer, so $6.87. That's that right there. My new balance I'm going to find by taking my beginning balance and adding on my finance charge. So I take my 434.26 plus my 687, and I get 441.13. These we could put dollar signs in front of all of them if we want. Okay. And then my minimum payment is going to take my 441.13 and it's going to multiply by the 0.05. And I get $22.06. So it's slightly less than last month, but still pretty close. And then in order to get my beginning balance, I take my 441.13, that was the total amount that Angie owed, and then subtract the payment that she makes of $22.06. And we're left with $419.07. And then there are just X's here because at some point we have to stop, okay? But that's kind of the entire process there. All right, let's take a look at the next question. Okay, so let's pretend that in an imaginary city there are 270,000 people. In a given year, there are 4,000 bicycle accidents. Calculate the per capita bicycle accident rate, round to the nearest thousandth, and interpret the value in a sentence. Okay, so per capita, if you guys remember, is just whatever you are interested in, or whatever you're asked about, divided by the population. Okay, that's always how you're going to find a per capita thing. So in this case, we are interested in bicycle accidents. So we take our bicycle accidents, which is going to be 4,000, and we divide by our population, which is 270,000. So we're going to get a pretty small little decimal here, but that's okay. We're going to round to the nearest thousandth. Let's see, so I get 0.0148, so we'll round that to 0.015. 0.015. All right, so that's going to be my answer, and then it asks us to interpret it in a sentence. So again, I'll kind of write this one out, I guess. I'll try to do a good job making it legible. But we can say that something like there are 0.015 bicycle accidents per person in a given year. And these are all just kind of made up numbers, so this is not actually accurate, but we're kind of in like an imaginary city here, all right? So this is going to be our sentence. So it's something like this. You can always use the same kind of structure. You just have to make sure you fill in kind of the correct number here, the 0.015, and then you're going to put something here, all right? In this case, we're talking about bicycle accidents, and then it's always going to be per person, and then kind of in this spot here, you can put like some additional detail if there's anything. So in this one, it tells you that in a given year. So it's nice to say that this is over like a 1-year time period. All right, so let's take a look at the next question. So, okay. So you have $10,000 to invest at a bank earning 2.8% interest. How much money will you have after 15 years? And this asks you about simple interest, compound interest. So in this case, I'm actually going to show you guys real quick. We have our formula sheet, okay? So I don't think we've used any of these yet or needed to use any of these yet. But down kind of at the bottom here, we have 3 formulas that are going to be helpful. There's I equals PRT. That's going to be this one that I kind of have in the middle here. And then there's the one right next to it that's balance equals principal times 1 plus rate to the power time. That one's also going to be helpful. And then there's the one right below it that looks really long and kind of complicated, but actually isn't too bad. So those are the 3 that we're going to be using here. So let me kind of go back to our question. So it says you have $10,000 to invest. So our first one that we're going to use is our I equals PRT, okay? So P is our principal. That's the amount that we're going to invest, which is our $10,000. Our rate is 0.028, so you always have to change your percent into a decimal. And then our time is 15 years. So we just multiply those 3 things. So I'm going to take my 10,000 times my 0.028 times my 15, and I get $4,200. So 4,200. That's the amount of interest that I earn, okay? So if I want to calculate the total amount that I have in my account, I have to take my $10,000 plus my $4,200. So that's my original amount plus my interest. So for this one, I'm left with $14,200. So that's going to be my answer there. Now, when you have compound interest, you should earn a little bit more money. So we should kind of make sure that each of our answers should get like slightly larger, because if it's compounded yearly, that means that every year kind of our balance is recalculated. Compounded monthly, it does that every month. So you're going to earn more and more interest every single month. So let's try the compounded yearly. So if we look back at our formula sheet, it's going to be kind of the second one that we talked to, the one next to I equals PRT. Balance equals principal times 1 plus rate to the power time. So I'm going to have balance equals principal, which in my case is 10,000, times 1 plus the rate, so 1 plus 0.028, and then an exponent is time. So it's going to look something like that. And then this is just a matter of plugging it into your calculator correctly, which if you're not sure how to do this, we did do a lot of examples in the section that covered this, so make sure to go back and kind of watch that lecture. And we should get an answer that's a little bit larger than our previous one. So I'm getting an answer of $15,132.01. Okay, so something like that if we round to the nearest penny. So that's going to be our answer for that one. And then compounded monthly, that uses kind of that third sort of ugly looking formula that's actually not that bad once you get into it. So it's balance equals principal. It looks a lot like our previous formula, except in this case, you take the interest rate, 0.028, and you divide it by whatever you're compounding by. So I'm compounding monthly, so that's going to be divided by 12. Close your parenthesis, and then in your exponent, you have whatever you had before, which was the 15, but then you multiply by whatever you used in your denominator here. Okay, so that number and this number are always going to match. Now, one recommendation that I gave in the class is to go ahead and do whatever is in your exponent first. So 15 times 12 is actually just 180. So I'm going to cross it out and write 180. And then when I go to plug this all in my calculator, it's actually pretty simple. It's just about as easy as it was last time. So we're going to do our 10,000, put our parenthesis, 1 plus 0.028 divided by 12, close our parenthesis, and then do our exponent and type 180. And I should get a slightly larger number than last time. I'm getting $15,212.17. So that's going to be my answer there. So you should always be able to kind of make sure that your answers make sense compared to one another based on how often it's compounded. So if it was compounded daily, that would be even slightly larger. All right, let's take a look at the next one. All right, so this one's a GPA calculation. So what we have here is we have 4 different classes that someone is taking, and then we have their credit hours, and then their actual grade. So what we're going to do is we can't multiply like 4 times B and 2 times C. So what we need to do is we need to put like a number with this grade. So B is actually 3 points, so I'm just going to write a 3 there. A C is 2 points, an A is 4 points, A is 4 points. Okay. So then what we normally do here is we create a little column called multiply, and then we just multiply. So let me draw some little columns there. So 4 times 3 is 12, 2 times 2 is 4, 2 times 4 is 8, and 3 times 4 is 8, or it's 12. Whoops. Okay, let me make sure I did all those right. 4 times 3 is 12, 2 times, okay. So then all we do is we add, all right, so we sum those up. So we do 12 plus 12 plus another 12 is actually just 36, all right? And then the other thing we have to do is we have to add up all of our credit hours. So in this case, they have 4 credit hours for history, plus 2 more is 6, plus 2 more is 8, plus 3 is 11. So we have 11 total credit hours, and we earned 36 total points. And then all we have to do is just divide. You take the total number of points that they earned, divided by the total number of credits that they're taking. If we do this, 36 divided by 11, we get 3.27, kind of repeating. So we'll just say 3.27. That's our GPA. The thing that you always want to do is kind of make sure your answer makes sense. If someone has straight A's, then they should be getting a 4.0. If someone has straight B's, they should be getting a 3.0. So this person has between like an A and a B. So if we look at kind of what makes sense, this kind of does make sense, right? They have two A's, they have one B and one C. So maybe that A and that C kind of cancel each other out, and then we're just left with an A and a B. So we have a grade that's right between A and B, which does kind of make sense. All right, let's take a look at the next example. Okay, so Joan wishes to purchase a $100,000 home. She receives an offer from a lender of 4.5% interest over the course of 15 years. She is comfortable putting 20% down on her home. What is her down payment? Okay, so to calculate down payment, all we do is we take the total amount that she is lending out and multiply by the percentage. So she's going to put 20% down. So I'm going to multiply by 0.20, or just 0.2. And this is an easy calculation. This is just $20,000. It's a little messed up looking, but $20,000. So she's going to put $20,000 down. So then to get her loan amount, what we have to do is we have to take the total amount, which was $100,000, and subtract the amount that she was borrowing, the amount that she was paying, which is $20,000, and then that leaves us with $80,000. So that means that for her $100,000 house, she is going to put in $20,000, and the bank is going to lend her $80,000. So those sum to $100,000. And then we want to write out the Excel formula for figuring out her monthly payment. So this is going to be equals PMT. So PMT helps you figure out payment. And then we put a parenthesis, and then we do her interest rate, which is 0.045. We divide by 12. We put a comma, and then we do 12 times the number of years, which is 15. And then we put another comma, and then we always put a negative sign, and then we have to put in how much she is borrowing, which in this case is going to be $80,000. And if you remember, don't put a comma in the $80,000 because otherwise kind of Excel will think that you're doing something strange. So I'm going to actually go ahead and open Excel because the next part asks, what does Excel return? So let's go to Excel. Open up a blank workbook here. Okay. So this one, we said we were going to use equals PMT. And then it tells us we're going to put the rate, which is going to be, 0.045. We want to divide by 12. And then we put a comma. And then we're going to put 12, I think we had times 15 years, and then we put a comma, and then we're going to put our little negative sign, and then she was borrowing $80,000, and then we'll close our parenthesis, and let's see if it likes how I did this. Oh yeah, it's doing something weird here. Okay, something like that. Okay, so there's my formula there. Let me open up my other workbook and make sure that was all right. 0.045 divided by 12, 12 times 15, and negative 80,000. Yeah, so that looks good. So this gives us an answer of $611.99. Now, of course, you're not going to have Excel on your actual exam, so it would actually tell you Excel returns a value of $611.99. It would give you that. Okay. So next question is, how much will she pay over the course of 15 years? So she's going to pay $611.99. She's going to pay that every month. So we're going to multiply by 12, and then she's going to do that for 15 years. So then we're going to multiply by 15, and let's see what we get. And I get, let's see, $110,158.2, or I'm going to put a 0 on the end, so 20 cents. So she ends up paying a total of $110,158.20. So that's the total amount that actually comes out of her pocket. And then how much has she paid towards interest? So for this, all we do is we take our previous answer, okay, this one right here, and we subtract the amount that she was borrowing, which is $80,000. Because if you think about it, out of that 110,000, basically 80,000 of it went directly towards paying off the house, but then the remainder actually went towards interest. So if we go ahead and subtract those, we should get $30,158.20. So she pays about $30,000 in interest. The other 80,000 goes towards the house, so that matches up to the total of 110,000. Okay, let's take a look at the next question. Okay. A marathon is 26.2 miles. Calculate how many centimeters this is. All right, so we're going to start with our 26.2 miles. We're going to put it over 1. Since I have miles in the numerator, I'm also going to put miles down here. And then I know I have a conversion from miles into feet, so I'm going to use that. Since I have feet in the numerator, I'm going to put feet down here. And then I'm going to do feet, I think, into inches. And then we also have a conversion from inches into centimeters. So let me go back to the formula sheet for just a minute. So if we go kind of up here, this is where you're going to have all your formulas. So I have feet into inches. I'm going to use that one. Miles into feet. I'm going to do that. And then down here, I have under length for the metric and US customary, I have inches and centimeters. So I'm going to use that as well. So this is kind of a little bit of a process to figure out how to get from one thing to the other. But if you just kind of think logically through, okay, what can I change miles into? And then the only conversion I have is 1 mile and 50 to 80 feet. That's the only one that I'm given. So I'm kind of stuck with that. And then I could change feet into yards, but that doesn't actually help me because then I can't get from yards to centimeters. So I'm going to change feet into inches. So 1 foot is 12 inches. And then I believe 1 inch is 2.54 centimeters, but let me double check that on my sheet. Yeah, 1 inch, 2.54 centimeters. So then this is actually really easy to multiply because I'm just left with 1 in the denominator. And then let me pick a different color real quick. If we look at what's going to happen, miles go away, feet goes away, inches goes away, and I'm left with centimeters, which is exactly what I wanted, okay? So all I'm going to do is multiply this in my calculator. So I get 26.2 times 5280 times 12 times 2.54, and I get a quite large number. Let's see, 4216481.28. Let's see if that's right. 4216481. Okay, put some commas in there so I can read it. So 4,216,481.28 centimeters. So pretty far, all right? We know that centimeters are a fairly small unit of measure, so it does make sense that we get a pretty large answer out for that one. All right, so let's do a Z-score question. So Catherine received 73 points on her exam. This exam was approximately normally distributed with a mean of 67 points and a standard deviation of 4. What percentage of people scored higher than Catherine? Okay, so in this case, I think I'm actually going to draw a picture. All right, we have like a Z-score kind of thing down here. So let's go ahead and take a look. Let me see if I can erase this. Oh, no, okay. That's all right. So let's go ahead and just write over it. I'll pick red again. That was pretty easy to see. Let's pick a thicker marker. Okay, so in the middle, I'm always going to put my mean, which in this case, it tells us that the mean is 67 points. So that means 67 is going to go here. And then I always add going one direction and subtract going the other direction. So I'm going to add 4, so I get 71, add 4 again, 75, add 4 again, 79, and then subtract as well. So 67 minus 4 is going to be 63, minus 4 again is 59, minus 4 again is 55. All right, so there is my little picture, kind of. Now I do want to kind of draw Catherine on here. So Catherine got a 73, so that's between the 71 and the 75. So it's going to be somewhere right around here. And then what I actually want to know is I want to know what percentage of people scored higher than her. Okay, so it's going to be this little shaded part. We know that the area under the entire curve is 100% or 1, okay? So I just want this little part right here. So it's not huge, all right? So we should get like, I guess I would say like a fairly small percentage. But let's go ahead and work it out and see what we get. So z-score formula is x minus the mean divided by standard deviation. And this is, let me pull up our formula sheet. This is on here, okay? So we have our big z-score table, which we'll use in just a minute, but right below it, it tells you this formula, z equals x minus mu divided by sigma. So you have to know what those symbols stand for, but if you know what that stands for, then you should be kind of good to go. So x is always your data item. It's whatever you're being asked about. So in this case, it's the 73 points. And then we subtract the mean, which is 67, and we divide by the standard deviation, which is 4. Make sure in your calculator you do 73 minus 67, hit enter, and then divide by 4. And I get an answer of 1.5. So that's the z-score. And then you always want to make sure your z-score makes sense. So in our case, Catherine, she scored higher than the mean. So it does make sense that it's positive. And then if we actually look, here's our mean right here, 67. She scored one whole z-score, and then, or sorry, one whole standard deviation, and then another half. So that's why this is 1.5. So then what we do is, let me draw a little arrow, and I'm going to write the word table, because we're going to go to our table and look it up. So I need to go to my z-score table, and I need to look for 1.5. It's going to be in the right-hand most column. It's 1, 2, 3, 4, 5 things down. And it's 0.9332 is going to be the number that we see when we look up 1.5. So I get a value of 332 or 322? 9332. Okay. Now, if you think about it for just a minute here, that would be 93.32%. All right, so if we gave that as our answer, that would say that this little blue part right here is 93.32%, but that doesn't seem quite right because this looks like a really, really small percentage. So actually what we found, and what we always end up finding, is the part that's to the left. So we found this whole shaded area. All right, so this is 0.9332. All right, this whole section. So anytime you look your value up on the table, you're actually looking and you're finding this right here, 93.32%. All right, that's always how it works. Whenever you look something up, you're always finding the value to the left. Now, if we wanted this value to the right, we want this little blue part, okay? All we have to do is we have to take 100%, because that's our total, and subtract 93.32%, and that gives us our little blue part. So we're taking the entire thing, which is this 100% from here to here, and we're taking away this black shaded area, and then we're left with this part right here. So I believe when we do that, we should get 6.68% as our answer, and that looks a little more reasonable. So if we're talking about just that tiny shaded blue part, it makes a lot more sense that that would be 6.68% instead of 93.32%. All right, let's take a look at the next example. So this one, we have an adult takes 200 milligrams of ibuprofen. Each hour, the amount of ibuprofen in the person's system decreases by about 17%. How much ibuprofen is left after 5 hours? So this is actually going to be an exponential question, and I believe, let me look at our formula sheet for a minute. I think we have something here that will help us. Yeah, so the last formula on the entire sheet is exponential growth and decay. Amount equals initial amount times 1 plus % increase or decrease to the power of time. So let me go ahead and write that out on our paper here. So amount equals initial amount times 1, and then it's either plus or minus the % increase or decrease depending on what you have, and then it's to the power of time. All right, so something like this. So in our case, let's go ahead and like plug in some of these values. So initial amount is the amount that the person initially takes. So that's going to be the 200 milligrams. So I'm going to have amount equals, go ahead and use some color coding. So it's my 200. And then I'm going to have times 1, and then this is a decrease type question. So I'm going to have 1 minus, and then this is decreasing by about 17%. So I do 1 minus 0.17, so you are always changing it into a decimal. If it's increasing, you do 1 plus 0.17, and then the power is time. So in our case, 5 hours. So it's going to be to the power of 5. So I have something like this. So I'm going to do amount equals, and then I'll go ahead and simplify this a little bit. 1 minus 0.17 is 0.83, and then I have the 5th power. You could just do the entire thing in your calculator all at once. Doesn't matter. And I get an answer of 78.78, and then this is going to be milligrams, all right? So basically what's happening is every hour that ibuprofen is in your body, it's saying 17% of it goes away. So for the first hour, you lose 17%. Next hour, you lose 17%, 17%. And so you're left after 5 hours with just 79 or so milligrams left in your body out of the 200. All right, so let's take a look at the next example. Okay. The cost of pizza in 1995 was $9.99. If the cost has kept up with inflation, what was the cost in 2011? All right, so if you guys remember from when we would do these in class, we put 1 year on one side and 1 year on the other side, and then we always put dollars, and then we put the CPI value, all right? So you do not have to set it up like this, but it does tend to work kind of nicely. So now all I have to do is fill in my CPI value, which 1995 is 152.4, and then I can't see what my other value is. 224.939 is the other value, 224.939. So if you guys have a question like this on the test, they'll give you the CPI value. And then all you need to do is fill in your dollar amount that you're given. So cost of pizza in 1995 was $9.99, so I just put $9.99 there, and then I stick an X right here, and I cross multiply. So I do my 152.4 times X equals $9.99 times, kind of ran out of room, 224.939. But I know you guys all know how to solve these. So let's go ahead and just cross multiply and divide and see what we get. I know you guys are all experts at solving proportions now. I'm getting an answer of like $14.75 if we round to the nearest penny. All right, so something like that. $14.75. All right. Kind of makes sense that our value went up because it's talking about pizza in 1995 and then pizza in 2011. So our 2011 value should be higher. So it shouldn't be a ton higher, all right, but it went up by a few dollars. All right, let's take a look at the next example. Okay, so if Kathy deposited, If Kathy deposited $300 each month for 30 years into a 401k, paying 5.5% annually, and her employer matches 50% of her contributions, answer each of the following questions. Okay. I forgot to change the name. So this is Julia, should be Kathy, okay? But how much money will Kathy have contributed over the 40 years? So she personally puts in $300 each month. So we're going to take 300 times 12. That will figure out how much she contributes in a year. But she does this for, I just botched this question here. 30 years. Kathy. Let's change these to all to 30 years. Sorry about that. And 30. Okay. So we're going to take the 300 times 12 times 30 years of contributions. And let's go ahead and multiply those. 300 times 12 times 30. And I get 108,000. So that means that she's actually putting in $108,000. All right, that's her own money that's going in. But then her employer is also going to put money in. So it says her employer matches 50% of her contributions. So this one we did two different ways in class. I'll show you both ways real quick. If they match 50%, that means that they put in $150 every month. So you could do 150 times 12 times 30. Or you can just take the 108,000 and divide it by 2 because they match half of it. All right, either way is totally fine. We should get 54,000, whichever way we do it, doesn't really matter. So if you take the 108 and divide it by 2, or you multiply by 0.05, or sorry, 0.5, not 0.05, you should get 54,000, or you can take 150 times 12 times 30. So then to figure out the Excel formula, this one's going to be equals FV. FV is always used for future value for 401ks. And we take the APR, which is 0.055, we divide it by 12, we put a comma, we put 12 times the number of years, so it's 12 times 30. And then the last thing, this is always the trickiest, this is going to be the monthly dollars, okay? And it should be the total amount. So she puts in $300 and her company puts in $150. So actually into her account, there are $450 going in there every month. We always put our little negative symbol, okay? So this is going to be $450. That's probably the trickiest part of this one. So always just make sure that you're adding together the person's contributions and the company's contributions. So let's go ahead and open Excel back up. So 5.5, 30 years, 450. Okay. All right. Okay, let's put it here. So equals FV, and then I think it was 5.5, so I'll do 0.05, oops, 0.055 divided by 12, and then put a comma, oops, and then 12 times 30, oops, not so good at typing on this, and then I think it was $450, so I put negative 450, and then let me just check this, 5.5, 30 years, 450, 5.5, 30 years, 450, okay, that looks good. Hit enter, and we should get $411,125.35. All right, so 411,125.35. 411,125.35. Check that. Yep, okay. So that's part D. That's the balance at the end of 30 years. Again, on your exam, you would be provided with that balance because you're not able to calculate it. You could be asked part C, which is to write the Excel formula, but you would be given the balance. So then how much did she earn in interest? So what we need to do is we need to take the total amount that she has in her account. All right, that is her balance. And then we take away all the money that she put in, which was $108,000. And then we also take away the amount that her company put in. Because the idea is it's asking how much interest. When you look at the total amount that's in the account, the 411K, basically it comes from two places. There's interest, and then there's contributions. All right, we know the contributions. It's the 108 and the 54. So in order to get the interest, we take the total amount that's in her account, we subtract the contributions, and then we're left with the interest. So if we do that, if we take the 411,125.35, we subtract 108,000, and then we subtract 54,000, we should get 249,125.35. 249,125.35. All right, so something like that. So almost $250,000 in interest over the course of those 30 years. So one thing I will point out here is you could be asked part E, if you were given the answer to part D. So on the exam, if you have something like this, they might give you the answer to part D and then ask you question E. All right. Take a look at this one. So Paul is on a weight loss journey. In the year 2000, he weighed 350 pounds, and then in the year 2010, he weighed 225 pounds. Find the slope, which is the unit rate of change, okay? So I'm actually going to draw a picture for this one. So this, I have my little X and Y axis. I have the year 2000, and then I have the year 2010, and then I'm going to have pounds over here. So in 2000, he weighed 350 pounds, so that's going to be this point right here. And then let's just put 225 down here. That's going to be this point. So if I connect these two, that's my line, okay? I can tell right away that my slope is negative, okay? And that makes sense because he's losing weight. So if we look on our formula sheet, we do actually have a formula for slope on here. Change in y over change in x. So it's kind of in the middle at the bottom there. So change in y over change in x. So once you draw yourself a picture, it should be pretty easy to figure out what the change in y and what the change in x are. So y is going to be, that's your y-axis over here. So you're going to take your 350 pounds and you're going to subtract your 225. Now it doesn't actually matter what order you do this in. Okay, you could do 225 minus 350. That would also be fine. You just need to make sure that you're consistent. So in the denominator, when you do your 350, you know that that goes with the year 2000. So that means you should put 2000 right below it. And then you know that the year 2010 is the one that goes with 225. So you have to make sure that those are also grouped together. So if you go ahead and subtract 350 minus 225, you should get 125. And then if you subtract in the denominator 2000 minus 2010, you get negative 10, okay? And then if you divide those two things, you should get negative 12.5, okay? So that should be your slope there. Now you could do that all at once in your calculator if you want. You just have to put parentheses around the numerator and parentheses around the denominator. Either way it works. So 12.5, but it's negative. And then it asks us to interpret the value for the slope. So we can say something like, Paul is losing 12.5 pounds on average per year. So something like this, all right? So it doesn't need to be perfect. You're always going to have to kind of fill in some kind of context in the underlined parts, all right? So that's going to change depending on what type of question. But there's kind of like a standard way that you can set it up, all right? You could say for every year Paul is losing 12.5 pounds. That would also work. Or Paul's weight decreases by 12.5 pounds, something like that. So this last question is asking us to construct a linear model. So this is actually also on your formula sheet, y equals mx plus b. So the y and the x actually stay put. M we have to plug in. That's what we just found. That's that negative 12.5. And then plus b, that's our starting point. So in this case, you can either use 350 or 225. It doesn't matter. If I use 350 though, the thing that you need to keep in mind is that that means that I used the year 2000. 2000 is the starting point, okay? So then when I actually go to estimate what his weight was in 2003, what I'm going to do is I'm going to take y equals negative 12.5 times something plus 350. And then in order to figure out what I plug in for my x, if I know 2000 is the starting point and I want to figure out what he weighed in 2003, that means it's been 3 years. So I just plug in a 3 for x. So then all I need to do is negative 12.5 times 3 plus 350, and I get 312.5 pounds. All right, so something like that. So the other way that you could get this is just to kind of think through it logically. If he weighed 350 pounds, he loses 12.5 pounds, and then he's going to do that from 2000 to 2001, do the same thing from 2001 to 2002, and the same thing once more from 2002 to 2003. You just subtract 12.5 three times, and you get the same answer of 312.5. So that's just kind of a nice thing to do. Make sure you're kind of thinking about, like, logically, does my answer make sense? All right, let's take a look at the next one. Okay, renting an apartment costs $870 per month plus a non-refundable deposit of $1,500. Create a model that gives the total cost for a given number of months rented. Okay, so it asks us what the Y variable stands for. So let's draw ourselves like a little picture here. Okay, so if you remember, this is always X, this is always Y. Anytime you have time, that's going to go along your x-axis. So in our case, we have number of months. And then our other variable is dollars. Okay, so the total amount of money. So in our case, what does the Y variable stand for? We can do something like total dollars spent. And then what does X stand for? Number of months rented, something like that. It's asking what the y-intercept or the starting point is. So I'm going to draw like a little picture here. I know that I'm going to have a line that looks something like that, because what's going to happen is as I rent for more and more time, I have a total amount of money that I've paid that is going to increase and increase and increase. So in this case, the starting point is actually this right here, non-refundable deposit of $1,500. So that means that before you even actually start to pay your monthly rent, you are going to pay $1,500 for a non-refundable deposit. So that's actually my starting point here. And then the slope, that's the rate at which Y changes when X increases by 1 month. So in our case, that's our monthly fee of $870. So this is like a slightly different version of the last one that we did. The last one we had to calculate our slope. This one we can actually just read our question and it tells us what our slope is. So then it asks us to put our pieces together to form an equation. So y equals mx plus b, so I have 870x plus 1,500. So that's going to be my model, okay? And then what does it cost for 1 year? Well, if we carefully plug in our value, I don't know what y is, that's what I'm trying to find. X, though, is number of months. 1 year is going to be 12 months. So I'm going to multiply my monthly rate by 12. And then I'm going to add on that $1,500 that I have to pay. And that should give me my total amount. So I have 870 times 12. That's my monthly rent, plus the $1,500 that I had to pay. And that gives me $11,940. Right, so there's my answer there. So this is fairly easy to also think through. If you were to think about it, if you were to figure out how much it costs you to live in a place for a year, you'd take whatever it was that you initially paid, which is your deposit, and then you'd multiply 12 times whatever you pay every month. All right, let's take a look at the next one. Okay. Adrian's car payment is 17% less than Luke's car payments. Adrian's car payment is $247. Calculate Luke's car payment. Okay, so this is the kind of question where we have 100 kind of on the bottom right, and then we do basically 100 plus or minus whatever percent we're given. So in this case, this is like a less than type question. So I'm going to do 100 minus my 17 that I'm given. So that should be 83. All right, so that's going to be this right there. And then all I need to do is I need to fill in the left-hand side. So I'm going to have 247 in one of the places, and then I'm going to have X in the other spot. So I have to very carefully think through who's paying more. So in my case, it says Adrian's car payment is 17% less than Luke. So that means that Luke has a higher car payment, and Adrian has a lower car payment. So that means that in my actual little setup here, I should put Adrian by the lower number. So he's going to go by the 83, and Luke pays more, he's going to go by the higher number, which in this case is 100. So then when I plug in my value, Adrian's car payment is $247, so A is on top, so I put my $247 here, and then I put my X here, and then we're going to go ahead and cross multiply. I'm not going to show the work for that. I know you guys know how to do it. So let me see what we get here. I get 297.59. So that's my answer there. Now you kind of want to think through this and make sure it makes sense. So Adrian's car payment is 17% less than Luke. So that means that Luke pays a little bit more. So he pays $297.59. So it's going to be that. This is kind of tricky to do in an equation format. If you just multiply 247 times 0.17 and add it on, you're not going to get the same answer. It's really important to make sure that you're thinking about it as Luke's car payment kind of being the base of this. So if you take now 17% of the new answer that we found and then subtract it, you'll get the 247, but it doesn't work like in an additive way. Less than and more than are not the same. So if I were to say that Luke's car payment is 17% more than Adrian's car payment, that's actually not true, okay? Because we're talking about 17% of a specific number. So this is kind of similar to a question that you had on another exam where it asked you if you increase something and then decrease something by the same percent, is it the same? And the answer to that is no, okay? So let's take a look at the next question. All right, put the following numbers, whoops, and this is the last one actually, in scientific notation. So 230 billion. So this is one, we're just going to write it out with all the zeros. So I'm going to have 230. This would be thousand. This is million. So that right there is billion. Okay. And then I'll go ahead and get a different color here. Here's my original decimal place. I want it in scientific notation though, so I want my decimal actually here. So I just have to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 spots. So this is going to be 2.3 times 10 to the 11th power. So I would always recommend that you kind of write these out the long way, and then you can go about changing it. Okay. Now 1.8 million, if you remember this, I told you guys to always just kind of ignore the little whatever's after the decimal. So I can actually just write out what 1 million is, which is a 1 with 6 zeros. And then if you recall, what you do is this little 8 actually takes the place of your 0. So it looks like that. So that's my 1.8 million. And then let's see, let's get a different color. Here's my decimal. I want to move it 1, 2, 3, 4, 5, 6 spots. So this is going to be 1.8 times 10 to the 6th. And then this last one here, I actually just have to move my decimal 1, 2, 3, 4 spots. So this is going to be 6.7 times 10, but then instead of just being to the 4th power, it's actually to the negative 4th power. So this is the kind of question where if you have, like, we refer to them as really large or really small numbers. If you have a really small number, you're going to have a negative exponent. If you have a large number, you're going to have a positive exponent. All right, so last slide I have here is just a recap of what you have to do. If you're watching this the last week, then this is true, but you might be watching this ahead of time. So the only things that you guys have, I believe, due the last week, and I don't think there's a discussion board, but you might want to double check. But you do have an exam 3 review, and then you do have to take your proctored exam. So good luck everyone on your test. If you have any questions, per usual, just feel free to email me and I'll make sure to get back to you. Or you can also use like the little inbox messages kind of chat feature that's in Ivy Learn. That will work as well. So good luck everyone.